Okay, so in this lesson we're going to be simplifying expressions, and this is part one. And in part one we're going to be identifying terms, and we're going to be discussing what are like terms and what are unlike terms. Because at some point in this lesson you're going to have to combine like terms. Okay, so recall though an expression. So in a previous lesson we talked about an expression. Remember, an expression is a collection of numbers, variable operations, symbols, variables, operation symbols, and grouping symbols. So in particular, let's look at this example. All right, so this is an example of an expression. So suppose we had 4x squared minus 3xy plus 2y squared minus 7x plus 6. So let's suppose we had this. All right, so that's an example of an expression. Now, what you need to be able to do is to determine, first of all, how many terms there are, how many terms this expression contains, and then also determine what the terms are, okay, how they're written. Notice that some terms, like this one right here, is a positive 4x squared. And some terms are negative, like this one right here is a negative 3xy. So you need to be able to know what the terms are. Okay, so first of all, when you have a variable expression, or when you have an expression like this, and in particular, you're going to learn about this later, but this is called a polynomial. But let's not worry about the word polynomial just yet. But in this expression, terms are separated by, and let's use the operation of addition. So terms are separated by the operation of addition. Okay, now I'll use the word addition. Okay, so you may say, well, there are some subtraction symbols in here. Well, yeah, but remember, in a previous course, you can always write subtraction as an addition problem. So this is going to be important. So if I had, let's say, 3 subtract 7, you can always write this as an addition problem. Remember the phrase add the opposite. So when you do this, you're going to be thinking of this. So this is the same thing as saying 3, and remember, we're going to add the opposite. So add the opposite of a positive 7. So 3 subtract a positive 3 subtract a positive 7 is the same thing as saying a positive 3 plus the opposite of a positive 7, and the opposite of positive 7 is a negative 7. So these two expressions are the same. Okay, so you can remember the phrase add the opposite. Okay, so what I need for you to be able to think about is this. All right, now in your mind you'll be thinking of this. So this is right here, this is written as in your mind, you're going to say 4x squared plus, remember this is subtraction, so you're going to say add the opposite. So plus a negative 3xy plus, so this is already an addition problem, so leave it like that. This is subtraction, so think plus a negative 7x, so add the opposite, and then plus 6. All right, so remember, terms are separated by the operation of addition. So we have addition, 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 addition. So we have 4 addition symbols. So here's a term. So this is term number 1. This is term number 2. This is term number 3. This is term number 4. And this is term number 5. So the question becomes, how many terms does this expression have? This expression has 5 terms. All right, so this expression has 5 terms. Okay, and then the next thing could be, what are those terms? So what are those terms? Or what are the terms of this expression? Let's write it that way. Right, so it's very important that you remember that as you're doing this right here, that you think of the subtraction as add the opposite. All right, so the terms are, all right, and we're going to separate them by commas. So the terms are, the first one is 4x squared, comma, the next one is a negative 3xy, not 3xy. So some students, when they look at this right here, they think 3xy. But remember, subtraction, if you have to, write as an addition problem. So add the opposite. So that's a negative 3xy. Then the next term is a positive 2y squared. Then the next term is a negative 7x. And then the next term is a positive 6. So those are your terms. So these are your terms. Okay? So when you do these problems, when you're dealing with polynomials later on as well, the idea of terms that come back. So remember, if you have subtraction, think of this as adding the opposite. So this is a positive 4x squared, a negative 3x, a positive 2y squared, a negative 7x, and a positive 6. Okay, now let's talk about a numerical coefficient. Let's talk about what a numerical coefficient is. All right. Numerical coefficient. Numerical coefficient. Okay, so all terms have a numerical coefficient. So keep that in mind. All terms have a numerical coefficient. Okay? All terms have a numerical coefficient. So, a numerical coefficient, definition, numerical coefficient of a term is the numerical factor. Is the numerical factor. All right, so in your mind you'd be thinking, what number am I multiplying the variable by? Okay, so that's what you're thinking of. So what number am I multiplying the variable by? So for example, let's suppose these are my terms, and then you're going to be asked to determine what the numerical coefficient is. All right? Okay, first one. Suppose we had 6x squared. So if you look at this, when you read this, this is read as 6 times x squared. And so my variable is x, and it's being raised to the second power, and the question becomes, what are you multiplying this x squared by? So what is the number you're multiplying x squared by? So I'm multiplying x squared by 6, the number 6. So therefore 6 is the numerical coefficient. All right, what about negative 8xy? All right, so that term, the variable is xy. The factors here of the variables are xy, and the question becomes what I'm multiplying xy by. So what is the numerical coefficient? What is the numerical factor? Well, the numerical factor is a negative 8. So remember, it's just that number. The numeral is just a number. Numerical factor is just that number. All right, what if you just had, let's say, y? All right, now when you think of this y, you see you may say, well, there's no coefficient there. I don't see a number. You're right, you don't see a number, but it's understood to be a 1. Isn't 1 times y the same as y? So this is just kind of like 1y. So the numerical coefficient is 1. So if you don't see a number in front, if you don't see a numerical coefficient, it's understood to be a 1. Same idea, suppose you had, let's say, negative x squared y. Suppose you had that. All right, well, I don't see a number, and that's being multiplied by x squared y, but it's understood to be a negative 1. Negative 1 in this case. Remember, negative x squared y is the same thing as saying negative 1 times x squared y. Okay? All right, what if you had this? What if you had, let's say, 2/3 x to the third power y squared? So 2/3 x to the third power y squared. Well, in this case, I'm multiplying x cubed y squared by the number 2/3. So the numerical coefficient is 2/3. All right, now what if you had this? What if you had, let's say, x divided by 2? X divided by 2. Now you got to be a little bit careful with this. You got to think about how you can write x divided by 2. All right, so you see this right here where I had 2/3 x squared y. I want to show you something. 2/3 x cubed y squared, rather. I want to show you something. So in a previous course, see how this right here is written as a fraction? I'm going to write all of these with denominators. I'm going to show you what I mean. So this is 2/3 times x cubed over 1 times y squared over 1. Okay? So remember, all this right here means this. It's because x cubed over 1 is still x cubed, y squared over 1 is still y squared. But if I multiply the numerators out, I'm going to get 2x cubed y squared divided by, and then 3 times 1 times 1 is just 3. So notice that this right here is the same thing as saying 2/3 times x cubed y squared. So the numerical coefficient of the x cubed y squared is this right here. So it's 2/3. So in the same situation, if I have this x over 2, and remember this right here is understood to be a 1 right here, so I can think of this right here, just draw a circle behind or enclose these numbers in a circle. So my numerator is 1 and my denominator is 2, so my numerical coefficient is 1/2. But remember though, isn't that the same thing as just saying x over 2 is just 1/2 x? So right here, this number right here is 1, so this same thing as saying 1/2 x. Okay? So if you had, let's say, real quick, if you just had, let's say y squared over 7, then that is just, right here, that is just saying the same thing as 1/7 y squared. That's what that is. So y squared over 7 is 1/7 y squared. Make sure you see this because using this idea here, when we did this right here, that's the same thing as saying 1/7 times y squared over 1, which is y squared over 7, which is what this is. Okay? So the numerical coefficient is 1/7. Okay? All right, now, so that takes care of understanding what numerical coefficient is. So you know what terms are. You know what terms are. You know how to find them. You know how to determine their signs, whether they're positive or negative. You know what coefficients are. Oh, one other thing I forgot to tell you, and I need to say it now. Okay, so still dealing with terms and numerical coefficient. All right, now you see how all of these had variables in it? Okay, and you see right here when we did this example here, this term right here, this term did not have a variable in it. All the others did. This term had the variable x as being raised to the second power. This term had the variables x, y, both being raised to the first power. This term had the variable y being raised to the second power. This just had the variable x, but this one doesn't. This one right here does not. This right here, just to let you know, that's called a constant. So that's a constant. So a constant is a term without a variable factor. And you're going to see later on why it's called a constant, because it's always constant. This right here is always going to be a 6. This right here varies, hence the word variable factor. It varies based on what you let x be, whatever number x is, whatever number x and y are, whatever number y is, whatever number x is. But this, since there's no variable, it's always going to be a 6. That's why it's called constant. Okay, so if I have a constant now, let's say I have the constant 8. Let's say I have the constant 8. And you see there's no variable. It doesn't matter. It's a constant term. It's a constant term, but the numerical coefficient is this constant. So my numerical coefficient is 8. All right, so a constant term. Remember, this is a constant term. These are not constant terms now. These are variable terms. Make sure you understand this. These are variable terms. See, they have variables, so they're variable. So these are variable terms because these terms vary depending on what x and y, or in this case, since we're using x and y, whether x is 1, x is -4, x is 3, y is 2, y is 7, and so on. But there's no variable here, so this is not a variable term. This is a constant term, and numerical coefficient is the same. So just to let you know, if I have, let's say, -6, then my numerical coefficient is -6. Okay? All right, now let's talk about like and unlike terms. Okay, so we're getting to the point where in the next lesson we're going to be able to combine like terms. But before we can combine like terms, we need to talk about like and unlike terms. Okay, so terms with the same variables raised exactly to exactly the same power or exponent are called like terms. Okay, so terms. So like terms are terms with the same variables raised to the same power. Okay, and so terms that aren't like terms are called unlike terms. So they're not like terms. They're called unlike terms. All right. So here are examples of like terms. And these will be examples of unlike terms. Right. And for the unlike terms, we're going to explain why they're unlike terms. Okay. All right. So here are examples of like terms. The first one, suppose we had 6x squared, 8x squared. These are like terms because remember, like terms are terms that have the same variable. Notice they both have x, and both terms, the x's are raised to the same power. So x being raised to the second power, x being raised to the second power. Okay. Now in the same light, these are not like terms. Suppose I had -2x, 6x squared. They both have the same variables, but the problem is that, remember that same power idea, the exponents are not the same. So this is exponent 1, and this is exponent 2. All right, so the reason why these are unlike terms is because they have the same variable x. They do have the same variable x, no issue with that, but different exponents, different powers. Okay? All right, now let's look at this one. Suppose we had -8xy squared, 2xy squared. All right, so notice they both have x's and y's. Both terms have x's and y's, but and in this, remember they're like terms. Okay, now but these x's have the same exponent, so that's 1, x to the first, and these y's have the same exponent, 2, 2. All right, so these are still like terms, even though the exponents are different based on the respectful variable. So in other words, even though this is a 1, this is a 2, that's okay. They don't always have to have the same exponent. In other words, if this is 2, that doesn't mean that this has to be 2. All this says is this: the x's have to have the same exponent, and they do. X to the first, x to the first. The y's have to have the same exponent, and they do. Second, second, squared, squared. Okay? Now look at this. 8x, 4y. 8x, 4y. These are not like terms. These are not like terms because they both have different variables to begin with. All right, so you see how this is an x, this doesn't have an x. This has a y, this doesn't have a y. Okay? So they're not like terms because of different variables. Okay? Different variables. All right, what about this one? Suppose we had 2x squared y and 1/3 x squared y. So these are like terms because both of those, the variables are, they both have the same variables. So x, x, y, y, and the respective variables have the same exponents. So x and x are both being raised to the same power. Y and y are both being raised to the same power. Okay? Now, what about this? 3xy, 4x squared y. So 3xy, 4x squared y. These are not like terms, these are unlike terms because even though they both have x's and they both have y's, the issue is not with the y, because the y are both being raised to the same power, y to the first, y to the first. The issue is the x's, the variable x. X here is being raised to the first, x here is being raised to the second. All right, so these are not like terms because although both terms contain the same variables, okay, although they contain the same variables, the variable x have different powers. Okay, so the variable x have different powers. Okay, now that should, I'm trying to think if there's anything. Oh, okay, let's look at this one. All right. Okay, so 4, 2/3. Now remember, these are constants. See how these have variables? These are constants. It's okay. All constants are like terms. All constants are like terms. Okay, all constants are like terms. You can't have any constant that's unlike terms. All constants are like terms. All right, so I'm just going to take this one off right here. Let's see. I think that should be it. If we try, let's say, one more with this. Okay, this is your like terms. Let's just not worry about this, and let's look at why these are unlike terms. Suppose we had 6x, 8. Now, notice this right here. This has the variable x. This is a constant, so it doesn't have the variable x. So these are not like terms. These are unlike terms, since both terms don't contain same variables raised to the same power. Okay? All right. So that should take care of this lesson. Now in the next lesson, we're going to take this right here and we're going to start combining like terms. Okay, what does it mean to combine like terms? Now in order to do that, you have to remember the idea of numerical coefficients, because you can be using coefficients, and you have to know that in an expression what your terms are, whether they're positive and whether they're negative. Okay? All right, so that takes care of this lesson.